researchers, and entrepreneurship future entrepreneurs. Brain or EEG controlled computer interfaced wheelchair. This is a project for research and entrepreneurship by Mukesh Bhardwaj. The agenda of the presentation is introduction, what is BCI computer interface, BCI, then timeline, then areas of growth, areas of focus, how we got there, and summary. This project discussed about a brain-controlled wheelchair based on brain-computer interface. BCIs are systems that can bypass conventional channels of communication, example muscles and thoughts, to provide direct communication and control between the human brain and physical devices by translating different patterns of brain activity into commands in real time. The intention of the project work is to develop a wheelchair that can assist the work independent on others. Here we are analyzing the brain wave signals. With this entire system we can move a wheelchair according to the human thoughts, and it can be turned by blink muscle contraction. By using this brainwave concept executed in wheelchair, the handicap will easily control wheelchair. What is BCI brain computer interfaces? This is the interaction between the human neural system and machines. The goal is to enable people, especially disabled, to communicate and control devices by mere thinking. BCI is a control system. EEG measures voltage fluctuations resulting from ionic currents within the neurons of the brain. Timeline: first 2 months are for literature survey, next first to third month is acquiring materials, first to fifth month experiment setup, sixth to 8th is obtain simulation results, 9th to 13th 12th month is web fabrication, testing is in 13th and 14th month, experimenting setup 14th 15th and 16th, debugging is 16th and 17th month, and documentation in last 17 to 18 months. Areas of growth: brain control. In the voice controlled wheelchair, brain control is not present. Voice control in voice controlled wheelchair is there, yes. Eye blink control in the voice controlled wheelchair not present. GPS not present in voice controlled wheelchair. Mobility is there, yes, in voice controlled wheelchair. Information to caretakers is not present in voice controlled wheelchair. Joystick is not present in voice controlled wheelchair. EOG control, electrooculogram eye signal based controlled wheelchair. Brain control is not there, voice control is not there. Eye or blink control is there in EOG controlled wheelchair. GPS is not present, mobility is present, information or message to caretaker is not present, joystick is not present. And GPS based wheelchair, brain control is not there, voice control is not there, eye blinking is not there, eye blink control is not there, GPS is present, mobility is present, information to caretakers is present, joystick is not present. In proposed wheelchair, EEG based, brain signal control based, brain control is there, voice control is not there, eye or blink control is not there, GPS is not there, and information to caretaker is not there, joystick is there. So rightly said, business opportunities are like buses, there are always another one coming, by Richard Branson. Meet our team: Mukesh Bhardwaj, Dr. Lokesh Arshne, Dr. Manish Upadhyay, and next anybody else like you. Areas of focus: Structure of a BCI. Signal acquisition. The EEG signals are obtained from brain through invasive or non-invasive methods, for example electrodes, after the signal is amplified and sampled. Second, signal pre-processing. Once the signals are acquired, it is necessary to clean them. Third, signal classification. Once the signals are cleaned, they will be processed and classified to find out which kind of mental task the subject is performing. Fourth one is the structure of BCI, computer interaction. Once the signals are classified, they will be used by an appropriate algorithm for the development of certain application. Cloud-based opportunities are there. This project discussed about a brain-controlled wheelchair based on brain-computer interface (BCI). BCIs are the systems that can bypass conventional channels of communication, example muscles, thoughts, to provide direct communication and control between human brain and physical devices by translating different patterns of brain activity into commands in real time. The intention of the project work is to develop a wheelchair that can assist the work independent on others. Here we are analyzing the brainwave signals. With this entire system, we can move a wheelchair according to the human thoughts, and it can be turned by blink muscle contraction. By using this brainwave concept executed in wheelchair, the handicap will easily control wheelchair. How we got there actually? The human brain is made up of billions of interconnected neurons. The patterns on interaction between the neurons are represented as thoughts and emotional states. Every interaction between neurons creates an electrical discharge. Alone, these charges are impossible to measure from outside the skull. However, the activity created by hundreds of thousands of concurrent discharges aggregates into waves which can be measured. Different brain states are the result of different patterns of neural interaction. These patterns lead to waves characterized by different amplitudes and frequencies. For example, waves between 12 and 30 Hz, beta waves, are associated with concentration, while the waves between 8 and 12 Hz, alpha waves, are associated with relaxation and a state of mental calm. Here a wheelchair is controlled automatically according to the brain signal. The brain signals are collected using brainwave sensor. Using these signals, wheelchair can be moved. Summary: to acquire and measure EEG signal. Second, however, the quality of electroencephalography signals is affected by scalp, skull and many other layers as well as background noise. Third, to remove noise present in the signal, that is denoising. Fourth, to build EEG recording system. First of all, electrodes are used, then amplifiers are used, then A to D analog to digital converters are used, and then finally recording device is placed. The electrodes acquiring the signals from scalp amplifiers process the analog signal to enlarge the amplitude of EEG signals so that the A to D converter, analog to digital converter, can digitalize the signal in a more accurate way. Finally, the recording device, which may be a personal computer or similar, stores and displays the data. Thank you. Thank you very much.